Okay, today we're going to look at what I've called advanced factorization. So just taking factoring one more step further. Again, you're always going to think in your head, is there anything that I can take out? This should always be your first step. So if we look at our expression here, notice that every single term, or every single coefficient, 3, 21, and 36 are all divisible by 3. So we can take out our 3, and we're left with x squared plus 7x, because 7x times 3 gives us 21x, plus 12. Okay? So that 3 does not disappear. That 3 needs to continue to stay here as we continue to factor. So now we've got a product and sum. Product of 12, sum of 7. We're thinking in our head, what two numbers multiply to 12, what two numbers add to 7, and we're setting up x times x because we have x squared. So x times x, and we know 4 and 3 multiply to 12 and add to 7x. So we don't lose this 3 coefficient in the front. We need to continue to carry that with us. So in the end, now this is fully factored. Okay, here, in this next example, we have a binomial squared, so we have x minus 2 squared. We have that same binomial, not squared, or to the first power, and then a constant. So actually, we can treat that binomial as we normally would an x. Normally we have x squared, like we did in the previous example, x to the first power, and then a constant. So here we're going to use x minus 2 as our x. Okay, and then in our heads, again, we're thinking we've got a product and a sum. We're thinking what two numbers multiply to 12 and add to 7. So plus 4, plus 3, and then we can simplify this. So we can combine our like terms. We can do 4 minus 2 and we get x minus 2. And we can do 3 minus 2 and we get 1. So x plus 1. Oh, sorry, this is x plus 2. 4 minus 2 gives us a positive 2. 3 minus 2 gives us a positive 1. Okay, so now it is fully factored. It's as simplified as we can get it. Another way to approach that is you could expand everything, but obviously that would take a lot more time than just simply factoring from this starting point. Okay. Next example. We have 2x plus 1 squared, the quantity here, and the same binomial here. So again, we can treat that like an x. We can create our sets of brackets, and we have 2x plus 1 instead of just x, and we have 2x plus 1. So when we multiply 2x plus 1 times 2x plus 1, we will get 2x plus 1 squared. In our heads, we're then thinking, what two numbers multiply to 2 and add to negative 3? So multiply to 2 and add to negative 3. So we'll need a negative 2, and we'll need a negative 1 to give us a positive 2 when we multiply them, and negative 3 when we add them. And again, we can combine like terms, simplify from here, so we have 2x minus 1 when we simplify, and 2x plus 0, or just 2x. And now it's fully factored. That's all we can do. Okay, so we have x minus 5 squared, and we have minus 2x minus 3 squared. So because of this minus, we have a difference, right? This minus is a difference, or in other words, subtraction. And do you see how we have two squares here? So we have a difference of squares. Similar to x squared minus 25, for example, where we can do x plus 5 and x minus 5. We can do the square root of x squared, which is x and x, and we can add the square root of 25 and we can subtract the square root of 25. So we're going to do something very similar here. We're going to take the square root of x minus 5, the quantity squared, or in other words, just x minus 5. And then we're going to add to one, subtract from the other, the square root of the quantity 2x minus 3 squared, or just 2x minus 3. Okay, and then it's just a matter of simplifying. So we've got x plus 2x gives us 3x. We have negative 5 minus 3 gives us a negative 8. We have x minus 2x gives us a negative x, and we have negative 8. Oops, we have to be careful to keep this in brackets. So we have negative 5 plus 3 gives us a negative 2. Yes, that's really important. When we minus our second term, it is important that that negative distributes to the 2x and to the negative 3. So we'll have x minus 2x gives us negative x, and negative 5 plus 3 gives us negative 2. Okay, so now that expression is fully factored. One more. Do you see here how we can factor out our x plus 4? So if we take out x plus 4 from both of these, we're left with 3 plus 2 times x minus 1. And we can distribute the 2 to both of these just to simplify things a little bit. So we have x plus 4, and then 3 plus 2x minus 2. And again, we can combine our like terms in the second bracket. So x plus 4 and 2x plus 1. Okay, so just some practice. This first example A is just like the one we just did. Let's see. Let's look at letter C here. So we want to take a look at both of those terms and think in our head, is there anything that they share that we can factor out? And we know that we can definitely factor out an x plus 2 from both of them. And also we've got the numbers 6 and 9. We have coefficients 6 and 9. They're both divisible by 3. So we can factor out 3 times x plus 2. And we're left with 2 times x plus 2. There's not enough room here. So this is letter C. 3 times x plus 2 times. So this gives us, when we multiply those, we get 6 times x plus 2 squared plus just 3, because 3 times 3 gives us 9 times x plus 2. And then again, you could simplify that. So we'd have 3x plus 6 times 2x plus 4 plus 3, or in other words, 3x plus 6 times 2x plus 7. Okay, and I'll continue to let you play with those examples, and I'll be sure you can see the answers on the following page. Maybe we could look at F as well from that one. So letter F, this one here. We look at all three of these terms and we think, okay, what do these share? And obviously we can factor in x plus 3 out of every single one of them. So we take out our x plus 3, and to get x plus 3 squared, we have to multiply x plus 3 times x plus 3. Then we have a plus 2, because we have 2 times x plus 3. And then we have a minus x. And then it's just a matter of simplifying those brackets. So we'll have x plus 3 times x minus x gives us 0 times 5. Or we can write that as 5 times x plus 3. Okay, just to show you some examples, the ones below, looking at letter A here, if we have a difference of squares. We have a minus, we have a perfect square here, and we have a perfect square here. 16 is a perfect square, so we have a difference of squares. So for letter A, we're going to take the square root of x plus 3 squared, or just x plus 3, times x plus 3, and then we'll have plus the square root of 16 and minus the square root of 16. So plus 4 and minus 4. And then we'll just simplify that. So we've got x plus 7 and x minus 1. Okay. Okay, just to show you another example like that, we'll look at B as well. So for B, we also have a difference of squares. There's a minus sign in between. 4 is a perfect square, and we have a perfect square here because our 1 minus x is squared. So we take the square root of 4, which is 2. We'll have 2 plus the square root of the quantity 1 minus x squared, and 2 minus the square root of the quantity 1 minus x squared. So 2 plus 1 minus x, 2 minus, and this is where we have to be careful to keep it in brackets, 1 minus x. Okay, so to simplify, we've got 2 plus 1, we've got 3 minus x, and what do we have? We have 2 minus 1, which gives us 1, and then minus the negative x, or plus x. So that should be it. That's fully factored. So again, if you want to continue practicing with these, and then check your answers on the following page. So you've got several examples to practice from here. And then here are the answers. And that's it for today. Thanks.